Alright guys, so we're going to talk about one other thing before we proceed with trigonometry. We're going to talk about reference angles. So here's what we're going to do. Remember, an angle in standard position is going to always be measured from where? The positive x-axis. Now that makes trigonometric functions what's called an abscissal function. That means they're based on the x-axis. Okay? So here's what we're going to do. All of our definitions occur within a right triangle. That means we can only use acute angles to fit our right triangle definitions. So if I want to find the sine of, say, 300 degrees, I'm going to run into a problem. 300 degrees does not fit into a right triangle. So here's what I'm going to do. I'm going to draw a 300 degree angle. Now you got to remember this guy here is 270. So 300 degrees is going to be somewhere like that. Okay, somewhere like that. And what I'm going to do is I'm going to say, there's 300 degrees. Where is the nearest x-axis? And make a right triangle. Okay, and that nearest x-axis happens to be 360. And so how far is it from here to here? Well, that's going to be 360 minus 300, which equals how much? 60 degrees. And we call this here our reference angle, and reference angles are denoted by theta prime. Now hang on to that because we're going to come back to it in just a minute. Okay, so theta prime, 60 degrees. Let's do another one, 135 degrees. All right, so I know 135 is somewhere between 90 and 180. I'm going to draw it right here. The nearest x-axis is there, and that nearest x-axis happens to be 180. So what do I know? 180 minus 135 equals, hopefully, 45 degrees. So theta prime, my reference angle, is 45 degrees. Boom, boom, boom. Okay? Now, what if we're dealing with radians? Well, the same is true for radians. What's the difference? You got to remember, right? 0, pi, 2 pi. This is a half of a pi, and this is 1.5 pi's, whether you like it or not. Okay, 3 pi by 2 is 1.5 pi's. So 7 pi over 6. Well, 6 pi over 6 is a whole pi. So 7 pi over 6 is slightly bigger than 1 pi, which means this thing has to be in quadrant 3. So there's quadrant 3. And if I go up to my nearest x-axis, what do I get? I get a right triangle. And my nearest x-axis happens to be what? Pi. So what have I got? I've got 7 pi by 6 minus pi. And 7/6 minus 6/6 is 1/6. So theta prime is pi by 6. Okay? Now I want to do a few angles that aren't pretty angles, because we keep talking about these special angles, pi by 6 and pi by 3 and 45 and 30. But what if we have an angle like 200 degrees? Okay, well, again, this is 180. So I know 200 degrees is somewhere out in quadrant 3. The nearest x-axis is still going to be there, 180. What is this angle here? This angle here has to be 200 minus 180, which is going to be 20 degrees. Our reference angle is 20 degrees. Now give me a minute, because I'm going to come back and hopefully make this make sense. But you got to be able to find reference angles first. What if I had 100 degrees? Well, again, this here's 90. So 100 degrees is going to be in quadrant 2, just a little past 90. Where is the nearest x-axis? The nearest x-axis is going to go like that. Ta-da. And we're looking for that angle right there. Well, what have you got? Your nearest x-axis is 180. So make an equation with those two. You got 180 minus 100, and you get 80 degrees. Theta prime is 80 degrees. Okay, 80 degrees. Cool. Let's do one more in radians, and then I'm going to circle back, and hopefully this will make sense. So 5 pi by 3. Well, I don't think in radians. So what have I got to do? I've got to come up here and label this thing and figure out what's going on. Okay, so there's my labels. Boom, 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 boom. And I think, well, how much is 5 pi by 3? Well, 5 pi by 3 is bigger than a pi. This, the numerator is bigger than the denominator, so it's definitely bigger than a pi. And 2 pi would actually be 6 pi by 3. So 5 pi by 3 is almost 6 pi by 3. So that means this thing's somewhere in quadrant 4. It's almost, the original angle is almost 2 pi. But I don't want the original angle. I want this angle right here. I go to the nearest x-axis. Okay? From here to the nearest x-axis is going to be 2 pi minus 5 pi by 3. And mathematically, this becomes what? 6 pi by 3 minus 5 pi by 3, which is equal to 1 pi by 3, or just pi by 3. And so theta prime is what? Pi by 3. And that's our reference angle. Now, let me show you something neat about this. Why do I need to know reference angles? Just because I can find them doesn't mean they're important to me. Why do I need to know them? So I've got my handy dandy calculator here, and I'm going to do just a little bit of math for you. Now, first things first, I want you to notice my calculator. I want you to notice that my calculator is in degree mode. Okay, so I'm not going to do the radian problems. I'm only going to do the degree problems. Now, I'm going to just play a little fun game. I'm going to type sine of 300, and you guys should be typing this along with me. And you get negative 0.866. Okay? Now type sine of 60, and what do you get? Same answer, different sign. Cosine of 300, 0.5. Cosine of 60, 0.5. Tangent of 300, negative 1.732. Tangent of 60, 1.732. What I want you to realize, folks, is that the sine, cosine, and tangent of this angle and the sine, cosine, and tangent of this angle are the exact same values. And the reason they are the exact same values is because of the similar triangular idea that we talked about in class already, that really and truthfully, sine of an angle is a ratio. And that ratio is the same because this 300-degree angle makes a 60-degree angle. This 135-degree angle is also making what? A 45-degree angle. Here's your 135. Here's your 45. I didn't actually change the graph. I just changed where I drew the lines at. Okay? So if we circle back to our previous page and use our all students take calculus, what quadrant are we in? We're in quadrant 4. All students take calculus. Now, all students take calculus. What does that mean? The cosine of this angle is going to be positive. The sine and the tangent are going to be negative. So what that means is I can actually find the tangent of 60, and because I know I'm in quadrant 4, stick a negative in front of this, and I get the same answer. Okay? Let's try a different one. 135 is in quadrant what? Okay, quadrant 2. So what that means is the sine of 135, all students, the sine of 135 should be positive. The cosine of the tangent should be negative. So let's find them. Sine of 135, positive 707. Cosine of 135, negative 0.707. And the tangent of 135, negative 1. How about if we use 45? Sine of 45, positive 0.707. Cosine of 45, positive 0.707. All I got to do is stick a negative in front of this. Stick a negative in front of this answer to get this answer. That's why it's important to know what quadrant you're in. And you're going to see this come up again and again and again in this class. And the question I'm going to ask you repeatedly, what quadrant are you in? Okay, because it matters. It matters a lot. Okay, so and of course the tangent of 45 is positive 1, and the tangent of 135 is negative 1. Why? Because your calculator thinks this is in quadrant 1. And your calculator knows that this is in quadrant 2. But they both make a 45-degree angle. So make sure you understand reference angles. Now let's try one that's not pretty. Okay? 200 degrees. Now here's what I'm going to do. I'm going to use my reference angle. So I'm going to type sine of 20. And I get 0.342. Now I got all students take. Now what does that mean? That means tangent's going to be positive, sine and cosine are going to be negative. So if you ask me the sine of this angle, it's going to be that number with a negative in front of it. Cosine of 20. You ask me the cosine of this number, it's going to be that answer with a negative in front of it. And here's the fun part. Tangent of 20 is that number. Tangent of 200 is also that number. Why? Because tangent's positive in quadrant 3. Okay? Let's try one more and see if this makes sense to you. Okay? So here our reference angle is 80, and we're in quadrant 2. All students. What does that mean? Sine's going to be positive. So sine of 80 is that number. Sine of 100 will be that number. What do you know? How about cosine of 80? Cool, there's cosine of 80. But I'm in quadrant 2, which means that needs to have a negative in front of it. Well, let's see if we're right. What do you know? Same number with a negative in front of it. How about tangent of 80? Tangent of 80 is going to be positive 5.67. Tangent of 100 will be negative 5.67. Cool. So reference angles. These are what allow our right triangle definitions to work in the other 3 quadrants. You need to understand your reference angles. They come in very, very, very handy, and they work very, very, very well. And so if you have the angle in standard position, the calculator will in fact always give you the correct answer. If you use a reference angle, the calculator will give you the correct quantity, but you may or may not have the correct sign. And that's why you have to know what quadrant you're in. So anyway, guys, that is reference angles, and you need to make sure you know these and can find them and understand them. I'll see you in the next video.